All right. Hello, everyone. So today we're going to talk about fractional replication of experiments. Hopefully, you're as excited as our friend Kermit the Frog over here. So the agenda today is just going to include what exactly fractional replication is, a fractional versus a full factorial design, and then we're going to go into a two-level factorial experiment. Okay, so what exactly is fractional replication? So this represents a significant technique in experimental design that allows us to reduce the number of treatment combinations tested. So sometimes we have experiments that are just way too big for us to evaluate with whatever resources we have. And so to cope with that, we can take a fractional of this replication, which is fractional replication, and we are still able to retain the same amount of accuracy for this experiment. So essentially, we can reduce the size, but yet we can include more factors without increasing our number of observations. Okay, so here is a full factorial design, and in this, the number of factors equals k, and the number of treatments equals 2 to the k. So, as we can see, this 2 to the k would increase the number of treatments very rapidly, as your number of factors increase very rapidly. So what we have, okay, so here we have the fractional factorial design where the number of factors is still k, however, the number of treatments is going to be 2 to the k minus 1 instead of 2 to the k. So now we have a two-level factorial experiment with there being three factors, A, B, and C. And so having these three factors with two levels results in 8 different treatments. And these 8 different treatments are all on the left side in orange. And so we have +1 for higher level, -1 for lower level. And what we want to do is reduce this number of treatments by 1/2. And this is how we get our fractional replication. And so when we do that, we're left with the top 4 rows. And those are the 4 treatments that we want. And when we do that, this allows us to analyze this experiment more accurately. So to tie this to engineering, let's say I'm doing a project where I'm analyzing a tensile structure, and the 3 factors I want to analyze are, so A will be pressure, B would be wind loading, and C will be forces. So when I'm combining those in an experiment, those are just some things that I want to take into account. So those are just examples of different factors that I can have. So yeah, thanks for tuning in.